Hello, this is ELB, and once again I am doing video game development in GameMaker. Last time we left off, I was trying to figure out the... Oh, and I have my own audio playing back on me. Hold on. Okay, that's not what I wanted. Alright, so anyway, last time I was trying to figure out the exact way to get objects to drop. Or not, well, yeah, pretty much anything lifted up. And I'm still kind of struggling with this right now. So, to recap, the red square is the square that the player is currently in. The blue square is the square that would ideally have the rock placed in it, but if the player is within that one, then it would be placed in the green. So, sometimes they are the same, sometimes they are not. But then we have this to show the red dot to show if the item cannot actually be placed. And even so, with all this, it's not, doesn't quite feel right, if that's the best way to put it. So here's what I'm gonna do. I'm gonna start over on figuring that out at least, because it is being annoying. So, here. This is all the code for it. I'm going to comment it out. Let's start again. Just going to be stealing this of the grid for the rocks. Okay. So, instead of going off of the distance from the middle of the player to the next grid over, I'm thinking it'll simply be based on, I mean, obviously it'll be based on the aim direction again, but we're not gonna worry about, like, that distance from the center of the player as much. So, here's what we'll do. First, let's get the spot that the player's in. So var no. Here. Player grid X. There we go. Equals player center X. Oh, come on. Times 16. And then we're going to be flooring this to ensure that it gives us a rounded number, essentially how many squares into the grid that it is. And then, of course, we times 16 to actually give the actual location on the screen of that point of the grid. Then we're going to be doing that for Y as well. Alright, so now that we have that, all we gotta do is draw rectangle color. We're gonna do var player grid X, var player grid Y, var player, oh come on, player grid plus 15. Oh, I forgot the X. Var player grid Y plus 15. Then the fun part, red, C red, C red, and C red. Once again, that's the constant for red. We'll have no it won't be an outline, it'll be filled in, but in that case, I should do this again. Draw set alpha to 0.2. That'll make it so that it will be mostly see-through. If it were set to 0.1, it would be even more. If it was 0.3, it would be less. 1 would be fully opaque. 0 would be, invisible. And that's exactly what I forgot to do, is fix that afterwards. There we go. Let's try that one more time. Oh, that was set to times 16, not divided by 16. I was wondering why I couldn't see the red square underneath the player. There we go. So as long as I have the middle of the character within this square, the square stays there. So that is the spot on the grid that the player is primarily on. Alright. So now we want 2 more. And these will be dependent upon the direction that the player is facing. So, here, let's do this. Oh, come on. Red square, and we'll make the next one blue again. Blue square. So, first off, we need the direction that the player is looking, and we need it rounded to ensure that it can't be just any direction, but instead one of the 4 cardinal directions, up, down, left, and right. So we're gonna do var player rounded aim. That's what we're gonna call it. So we're gonna do player aim direction divided by 90, so that it's one of those 4 directions. And we're going to round this to ensure that we either have 0, 1, 2, or 3 for the answer, timesing it by 90 afterwards. Okay, so that'll give us up, down, left, or right. Depending upon which direction the player is mostly aiming in. So if they're aiming down and slightly to the left, it'll just be down. If they're aiming more to the left than down, it'll be full on to the left. So, how do I want to do this then? So last time I was basing what the next square was going to be off of where they were looking, but I don't want to do that. No, but do I want to do that? Might make things a little bit easier. Although it'll be a lot more code again. Oh well. Var player. Okay, so var player. No, we'll call this just blue grid x equals length dir x. Oh, hold on a moment. Okay. So, length dir x, and that will be 16 as normal, since that is the size of the grid. And the direction, oh wait, yeah, 16 for the length. And then the direction will be that var player rounded aim. So now we can just do this again with length dir y to give us both the x and y coordinates based upon the direction. So now that we have that, we need to do it sorry for my silence there. We'll do x plus, y plus, and then we are going to floor these. Okay, oh, there we go. And then finally, times 16, and that should give us the square directly adjacent to us that we're actually looking at or aiming at. Okay. So let's try this then. Draw rectangle, color. Oh, fun little thing about GameMaker. It works with the American spelling, but then it doesn't give you the arguments for it. So you have to use the English spelling, and then it'll actually tell you the arguments. I don't know why. It's dumb, obviously. There, blue, grid, X. There, blue, come on, blue, grid, Y. There, blue, grid, X plus 15. No, 15. There, blue, grid, Y plus 15. Oh, come on. C, blue. Got 4 of them. Outline, false. Alright, let's see if this works. Which it should, hopefully. And we can already see that it's not. I'm curious why. Oh, I already know why. I forgot to do the dividing. So let's see. I had something to floor and I didn't even floor what was necessary. I think this will work. Alright, so we start off looking to the right no matter what, so I'll try looking up. Okay, left, and down. And, well, that is buggy as heck. That's not what we wanted at all. Okay. Wow, look at that. Okay. So, why did this happen? I think I know why. It was because instead of going off of the center of the player, we went off their x and y coordinates. Now remember, the origin is in the top left of sprites usually. So, x and y coordinates are right here, whereas we wanted to base it off of right here. So, here's where we will fix that. We want SCR player center X and SCR player center Y. Alright, let's see how this works now. Looking right, looking up, looking left, looking down. And there we go. It's based off of the exact same thing as that red square. So it's working exactly as it should. Alright. Give me just one moment. I seem to have a decent amount of messages. Okay. Back to it. So, Now that we have this, let's do it again for a third square, a green square. We would choose where to set down the object based upon whether or not we are in the blue square or not. So this ensures that we never accidentally put it on top of ourselves. You know, let's call this blue aim. And then we'll call, well, no, it doesn't need to be blue aim. Shoot, rounded aim is fine. Never mind. Okay. So var green grid x equals floor, all this. Okay. Except instead of being a distance of 16, it'll be double that. So 32. Just got to replace these with y. We're golden there. I'll just rewrite it. Draw rectangle color var green grid x var green grid y var green grid x plus 15 var green grid y plus 15. The color will of course be sea green, the constant for green, and it will not be an outline. Well, this is going swimmingly already. So why it's like that, I am incredibly unsure, honestly. This kind of surprised me. Because the green grid is supposed to be right here, not right there. So what did we do wrong? Oh, I know exactly what I did wrong. Forgot to replace that with length dir y instead of length dir x. And we already have the correct result. Alright. So now all we need is to determine whether or not something is in the way of us placing it where we want it, as well as determining which square we would place the object in anyway. Because right now it would go in the blue square. When I step slightly into the blue square, I need to drop the object into the green square. After all, we don't want to set the object on top of ourselves, which would mean we can no longer move. So, I think we already have a pretty good thing so far, so let's just remove that. So, this is how we're going to determine where we can place it. We're going to be using collision detection upon first the blue square, and then the green square. If the blue squares, or if we're in the blue square, then we check the green square. And if the blue square is filled with something else, then we cannot place anything down at all. So, let's start with cannot place anything down at all. If place meeting var blue grid x, var blue grid y, obj block, then this will happen. Otherwise, this will happen. This otherwise thing I'll draw up in a moment. Okay. So, now that we've checked to see if there's anything in our way, we're going to check and see if the player is within the correct or incorrect spot. So, let's check the documentation. There is one thing in particular I'm thinking of using for this, which would simply be not point in rectangle. Was it collision rectangle? Yeah, so collision rectangle checks to see whether any instance of a given object collides with a user-defined rectangular area. That user-defined rectangular area would, of course, be the square, or the blue square. And the thing that we're checking for is ourself, so we could either put ID here or obj test figure, and it should be fine. And then, of course, we have to have false for the not me thing, meaning it checks for itself. Yeah, I'll put that away. So, collision rectangle. I should put an if at the beginning of that. Collision rectangle. So we're doing var blue grid x, var blue grid y, var blue grid x plus 15, var blue grid y plus 15, obj, we're just doing ID, precise, false, we don't need any precision collision detection, not me equals false. Okay. So, place object on green square. Place object on blue square. And then for here, cannot drop object, or cannot place object. Alright. So, in this case, let's draw something simple. In fact, let's move this real quick. Draw, what do we have available? Button, circle, circle color, clear, ellipse. I don't know what some of these are. Well, let's just draw a circle. Okay. So, we will draw a circle on var green grid x plus 7, var green grid y plus, I said plus 7. This will put the circle in the center because the x and y coordinates for the circle are literally just in the center, and then we're defining the radius of the circle. So the radius will be, say, 4. Colors will be sea green, and it is not an outline. Then let's do the same thing for the one that we cannot place the object, or that we're not going to. Oh, we want blue grid. Blue grid x plus 7, var blue grid y plus 7. Oh, C red false. Okay. So that's going to be the exact same thing for this one, and I am missing something here, aren't I? I'm missing the radius. There we go. All we're doing is we're switching the colors here, because we know that it's going to be going in the opposite one. Alright. Then for not being able to place the object, both are going to be red. Alright. Let's see how this looks. And we already have a problem. So right now we're supposed to have blue being green and green being red. We have them both. Now it's even more wrong. So I'm curious what I did wrong here, and I'll probably find out in just a moment. Okay. So if place meeting. Oh. Let's try that, because I'm pretty sure I messed that up. Alright, we're already getting better results. We know that we want to put it in blue, and now that I've stepped into blue, we're putting it in green instead. Alright, now here we've run into a new problem. We know that we're in blue, and we know that we can't put it in green, because green is filled with something solid. But according to the game, it's not. So we need to fix that. We need that to be red when that happens. Okay, so this is checking simply if we're in that one. So we now need to check to see if there's an object in the other one. So we'll check this, green grid. Oh, come on. Okay. Let's bring that up. Then else. Cannot place object. Alright, let's give this another test. Okay, so far it's correct. We know that we can put the object down in blue, and now that we entered blue, we need to be putting it down in green. Okay, we know that we can put it out. There we go. Now that we slightly entered blue, we know that we simply cannot put the object down. These are the exact results we should be getting. After all, we don't want to be colliding with anything. We don't want to put the rocks down on top of ourselves like we did the other day. Anyhow. So, it seems like we've figured out the logic. It tends to be very useful to do that in like a very visual way to start with, simply so that you can work through the kinks before ever doing anything behind the scenes. Know what I mean? People are still messaging me. Hold on a moment. Okay. I am back. So, now that we've gotten that figured out, let's try to actually put down a rock. We're going to apply the logic that we just worked out for, well, for dropping the thing. Okay. So I removed the drop code. Real quick, I'm going to run it and pick up an object, aka one of these rocks. We got a rock. Can't put it down. But we know where we're going to be able to put it down. When I was trying to put down rocks originally, I was moving the player around. And that felt really weird, honestly. So what I'm going to do is I'm going to have the dropped rock be a solid object. It'll be the thing that gets put down, and then it will simply do a super quick animation of the rock moving to the ground. Because that's all we need. So, we're going to copy this over. Once again, I don't think I have mentioned this. You cannot do drawing in the step event. So, currently there is going to be all this in the step event. Of course, this does nothing here. Neither does this. This doesn't do anything. This doesn't do anything. And this shouldn't be here. Okay. So, okay, let's remove all these. Now let's start simply by being able to place it on the blue. So when we're dropping this, what we're doing is we're putting the pickup ID to equal no one, aka we're not holding anything. We're not holding any particular object. So what else do we need? We need to with obj parent pickup held. Here, I'm gonna look at this thing's code real quick to see what I'd done. Drop location, okay. If obj test figure pickup ID does not equal ID, then x equals drop location x, y equals drop location y. Okay, so it was this which was doing most of the code. So we don't need to do this. Instead, we do pickup ID dot drop location equals var blue grid x. But even that's not right, is it? Drop location x. There we go. Drop location y, y. Then this checks itself to see what it should change into. We're not going to change it into solid rock, we're going to change it into dropped rock. So that dropped rock can then take care of everything it needs to take care of. Okay, so let's give this a test. Now, for now, dropped rock will be something that we can just walk right through, and that's fine. Alright, we can see it. We're walking through it. We can't pick it up. That's exactly what's supposed to happen. Cool. So, now that we've done that, we're not going to make x equals drop location. We're not going to make y equals drop location. Well, no, we do need to do that, don't we? Instead, we're going to... I think x start is set when the instance is first created, but when you're changing the instance's object, it stays the same. But start events might change that. You can also set this encode to the value that you wish. Cool. So we'll just do that. X start equals x. Y start equals y, just to be safe. Okay. So now that it's doing this, we should... So what we're going to do is we're going to lerp between these two locations, or more like we're going to lerp where it's being drawn. This will be a really simple drop animation. So you might be asking right now, what is lerp? Lerp, it returns the linear interpolation of two input values by the given amount. So the first value, the second value, the amount to interpolate. So the easiest way to put it is if I have... Oh, here their example. 0 to 10, then 0.5 would return to me 5, because that's halfway between 0 and 10, right? If I were to have, say, 0 to 100, and I put in a lerp of 0.25, it would give me 25, because that's 0.25, or that's a quarter between 0 and 100. So using a quick lerp animation is a really, really simple way of doing it, which is fine by me. Theoretically, I could make it a little bit more complex and, make it have a slight arc, but for now, this is fine. This is all I need. So let's do this. We're gonna create a variable called animation lerp equals 0. Okay. Now every step, animation lerp will go up by 1. That's what the plus plus is. This is essentially the same thing as this. So animation lerp plus plus. But is that what we actually want? You know what? Instead, we'll do this. We'll do it plus equals 0.25. So we'll have it a 4-frame animation, which will be fine. Okay. So we're not going to be drawing it here. We're going to get var drop x, var drop y. Have I been doing this all in the wrong one? I have been. We don't want to do this in the held. Do we want to do this in the dropped one? Haha, I'm smart. Okay. Was there anything in here we needed? Okay. We're stealing this back. Doing the step. Now we're going to do a draw event. Here's what we're doing. We're going to var lerp x equals lerp between start x start and I think drop location x is hold on. It's always fun when you can't quite remember your own code. Pickup ID equals no one. Drop location. Well, that can't be. That won't work then. Here, we'll do this. Xstart equals obj player dot x. No, it's not obj player. Obj test figure dot x, and then obj test figure dot y. Okay. No, but even that's not right. Here I am getting mixed up. There we go. I believe this will work. So start, and then can we just do that? Yeah. X amount animation lerp, I believe it was. Yep, animation lerp. Y, and then I think if animation lerp is larger than or equal to 1, then instance change obj no, we want if object index equals obj, what was it, pickup dropped rock, because that's what it is, then instance change obj, what was it, pickup solid rock. Oh, and then true for the creation events. Alright, I think this will work. The only thing we need to change is have the parent be obj blocks, that once it's set down, things cannot walk into it. Alright. Well, I mean, it definitely was put down correctly, but we're not quite getting that animation still. What's going on here? Oh, I completely forgot to do the animation. So draw sprite. So we're gonna be doing it was sprite index, I think. The index of the current sprite for the instance, yes. And we're gonna have it be image index so that it'll be the current, come on, so that it'll be the current subimage as necessary. And then we'll do var lerp x and var lerp y. Alright, let's try this. Our ultra simple rock dropping animation. Okay. Wow, that is not what I expected at all. Let's see that again. It is going from way up there. What the heck? I don't know what's going on there. Okay, let's figure this out. We needed this, so x start and x. So x start equals obj just figured out x, obj just figured out y minus 16. Instead of having this be x start, let's have this be x start, because that makes things way less complicated. Oh, well, I already see where I messed up. I had it at x start still, instead of y start. In any case, let's see if this fixes it. All right. Our ultra simple dropping animation seems to work. The only thing I'd like to do is change the depth to -1 here as well, so that it goes over the player. I'm gonna sneeze. Bah. Oh, come on. And it's still not over the player. Okay, well, let's fix that real quick. I do? Oh, there we go. Invalid name, what? Oh, I didn't even realize that. OBJ, pickup, held, rock. Except for it's not, it's dropped rock. There we go. I don't think it would be unreasonable to have a real simple picking up animation as well. Well, that shouldn't be too difficult. Okay, OBJ test figure dot picked up ID equals ID. Drop location equals, and then let's do start equals X, Y start equals Y. This will have been before it gets moved, I believe. Yeah. Unless the player does that already. Let's check his code. Does not look like it. Cool. So let's do this animation lerp thing again. We're gonna... Okay, if animation lerp is less than 1, then... Or no, if animation lerp is larger than or equal to 1, then we'll do this. Okay, else we're gonna get and then X, and then the amount will be animation lerp. Var lerp Y equals lerp start Y animation lerp. Alright, then finally we draw sprite. Here, we'll do this. Draw sprite index, var lerp X. So this should technically be correct. Let's do if animation lerp is less than 1, animation lerp plus equals 0.25. Alright, let's see how this looks. Oh, nope. So start X was not set before reading it. Really? Oh, that's exactly what it was. I always do that. Which one did I even do? I don't even know now. Son of a gun. Oh my goodness. Okay. Come on. Which one was it? It was start Y. So it needs to be Y start. Okay. Or start Y. It needs to be start Y. There we go. Okay. I'm doing so well right now. Pick up. What the fuck was that? I mean, the animation looked fine, but why was that the one that just got picked up? I am so confused. Okay. I am gonna restart this for a moment. Okay. I think I never changed the code to only do the 4 cardinal directions when it comes to picking up, which is a problem. An easily fixable one, but a problem nonetheless. However, I want to do this real quick. There we go. Alright, I'm going to check my messages real quick. Okay. Cool. So let's fix picking up objects real quick. How the heck did I do this? I think I'm going to rewrite my pickup code to be more like the dropping code. Okay. We don't need this for loop. We really don't. Alright. Gonna take a drink. Okay. Okay, obviously we can't just have this floating code here doing nothing. It doesn't really make sense. So our red square, blue square, and green square are rather useful. The only problem that we have here is that if they are way back here, they can't help anyone else. So let's move them up by quite a bit. Having this sort of code here will be rather helpful for any other interactions that we have in the future as well. So let's call this player square next to player next to player. That should be fine. So if pickup ID equals no one, and then if pickup ID equals no one, why do I have that then? Pickup ID is going to be equal to no one anyway, so what the heck? Let's remove you. If pickup ID equals no one, then I wonder if we can just full on steal this code down here actually and use it again. You know, no. Here's what we're going to do. If place meeting var blue grid x, var blue grid y, obj parent pickup solid, then no, we don't even need to do that. And why did my music stop? Hold on a moment. I am still listening. Alright. Oh, where'd you go? Collision checking. So let's do collision rectangle. Okay. Var blue grid x plus 15. Var blue grid y plus 15. Then the obj is obj parent pickup solid. Precise, we don't, oh, come on. Precise equals false. Not me equals true. Technically we're not looking for ourselves, but we're not going to get ourselves through this anyway. Var pickup candidate equals, then if var pickup, come on, pickup candidate does not equal no one, we don't need this pickup angle thing. We just need that, actually. All right. I think that's all we need. Alright, well there's one thing I'm a little bit curious about now. I used collision rectangle right here. So I'm gonna do this real quick just so that I know exactly what it's doing. Let's try this once more. Okay. Alright. So var pickup candidate ID was not set before reading it. I'm gonna copy this real quick. Stick it in our good old notepad. So line 132. All it was missing was the ID, so it should be fine to just remove it. Let's try this. Look at that. Picked it up from exactly where we wanted. Gonna reset the room real quick. Now, although you cannot tell, I am trying my best to look into the corner, and I am picking up the correct one. Cool. Now we can have fun with this, right? I mean, I don't know what the use of making a line out of these would be, but yeah, we're picking stuff up and putting it down. Actually, there is one thing that we can do right now, which we don't want to be able to do, which I'll fix in a minute, which is that. Although, should I force the player to be touching the rock to be able to pick it up? Because right now they don't have to be touching it. Right? They just have to be close enough. For now I'll leave it like this. In any case, let's make it so that we can actually put the rock down in the other places, so that it's not finicky, which is what it would be right now if I didn't have those visual guidelines to tell me whether or not I can put it down or not. So, all we need to do is copy this code over to here, change this to green. Oh, come on. Green grid. And then I don't think we need these else's at all, actually. Oh, except for we did need this. Okay, if collision rectangle, no one else. There we go. This should be fine. Okay. So let's get a little bit of space there, and let's nuke that. Temporarily nuking it. It'll probably be useful in the future. Alright. You know, this might be a little bit easier if I can actually see where I'm aiming. There we go. It is a little bit funny that you then can't pick it up after you've placed it down again. Like immediately. So I'm wondering if that will cause issues in the future. In any case, I do need to make it so that I cannot place a rock on top of an enemy. So the easiest way to do that is to make enemies solid. And the easiest way to do that is to set this to obj block. And that should make it so that we cannot set the rocks on top of the enemies. Set it right next to him, cannot set it on top. All right. Now, if we had a lot of rocks, we could write silly messages, which we're not going to do right now. Instead, we'll kill that guy for fun. Okay. It has been an hour and 10 minutes. You know what? I think I'm going to call this good for now. I'll probably get back to this within an hour, maybe less. Or maybe far less. I'm not entirely sure. But that's good progress for about an hour. Next time, I will be making it so that we can throw the rocks, rather than just pick them up and set them down. It's always a lot more fun to throw shit at enemies. I'm ELB. Thank you for watching.